The next speaker will be James Cast from Toyota here in California. And the word is yours.
Excellent. Can you see and hear me okay? Fantastic. Let me just bring the screen up as well. And thank you very much for the opportunity to speak today, even though I know we're all virtual. Hopefully this is still a productive forum here. So now you should be seeing my screen. Okay. So again, thanks again here. My name is James Cast. I'm a hydrogen business development manager for Toyota based in Southern California, and really going to focus on a bit broader Toyota's electrification efforts, but really nailed down into the work we're doing in hydrogen and fuel cells. And that'll be mostly focused on light duty, but then there's many other applications too that we're looking to decarbonize using fuel cell technology. So let's go ahead and jump right in. So first, as a broader company, of course, we have an overall vision, and this started a number of years ago with our Environmental 2050 Challenge, which really aims to get our carbon intensity and carbon neutrality all the way down by 2050, and even moved up some of those goals into 2030, also just recently. And this really is not just the vehicles themselves and what emissions are at the tailpipe, but it's our whole business, including our water use, recycling, this overall harmony with nature, and even our N16 plants, for how we can continue to decarbonize the entire supply chain of vehicle production and use as well. And that itself is what is driving a lot of our innovation in a lot of different portfolio of approaches for newer and lower carbon solutions for vehicles. So here you see really it's the key solutions that we have, right? So we've been working on hybrid technology for now 25 plus years. And of course, you saw the initial Prius there in the late 90s. That really was the spearhead for cleaner, more efficient vehicle technologies. And now we've been growing along with that as well. Now going to more plug-in vehicles. You've now seen the BZ4X, the battery electric vehicle coming next year to the US, but then also on hydrogen. So the hydrogen fuel cell realm, many you don't know, actually started within Toyota also about 25 years ago. So that development really started at the same time as our hybrid development. And there's a lot of that synergy that eventually led to the release of our first vehicle about 5 or 6 years ago now. And now we'll kind of transition again. The focus really is on the Mirai. So our initial vehicle launched in 2014 and called Mirai for a reason, because it actually means future in Japanese. And the key here was just noting that we saw this as really the future of zero emission vehicle technology, or at least a very key solution. And this was going to be the prime focus that we were going to take to be part of this whole portfolio of a new technology. And with this vehicle, if we shoot the guts of the car here, it really just has the key components that you'd expect in any electrified powertrain. It's powered by an electric motor, but the energy storage is based on hydrogen. So you store the hydrogen in the vehicle, you create that electricity on board rather than storing it in the batteries, but still performs in many similar ways that you would to your typically battery electric or other electric type powertrains. And so this first vehicle, our initial Mirai, had a range of about 300 miles. And continues to be on the roads today with about 7,000 to 10,000 or so on the roads, both in the US and globally. But now we've gone to the next iteration. So the second generation Mirai actually just launched late last year and early this year in the US, was really the next iteration of technology to improve many aspects of this. So it was the efficiency, the fuel economy, the cost, the packaging, all of these things improving, including the range. So now going from a 300-mile vehicle with a major improvement to about 400 miles of range vehicle. And you may have also seen just recently that we had an announcement of a world record. So we were actually able to get a driver to get this vehicle to drive 845 miles just a month or two ago, which is really quite a feat for this type of technology in the state that we're in. You can see here, again, the guts of the vehicle a little bit different. So now we've actually moved the fuel cell stack from underneath the center of the vehicle to the front main hood area where you typically expect the powertrain. And it's also now a rear wheel drive propulsion as opposed to front wheel from before. So it's a much sportier, better handling. It actually sits on our base TNGA platform, similar to many other more sportier vehicles. And it really has greatly improved the driving experience, even compared to the previous version just a few years ago. So now you can see what the two vehicles actually look like side by side. You have Gen 1 versus Gen 2 on the right. And we've also improved not just the vehicles, but really getting into the production side of things. So the first vehicle was also a very high portion of it was hand built. You know, there was a lot of actual humans on the line, and we could make about 3,000 or so per year, which actually was really pushing our capability at the time, given the higher demand than we expected. As we've moved into the Generation 2 technology, there's now much more automation, and we pushed that about tenfold, looking at about 30,000 total units of production per year to service the needs of not only light duty, but some of the other applications that I'll get to in just a moment. But of course, as we continue to go on vehicle cycles, the production line continues to increase and improve, just like the vehicles themselves, and you'll see that with future announcements in the future years. The one thing I do want to make clear as part of this conversation too is the infrastructure in a lot of ways is as important, if not more important than the vehicle sometimes at the end of the day. And so here I'm just highlighting really the myriad of partners that we've worked with on the infrastructure side to ensure that the fueling network is expanded and performs as what is needed to meet that customer experience. And it's really adapted in a long time. So you see a kind of a myriad of different startups and industrial gas companies getting to larger oil companies and energy companies. And it's starting to become this breadth of different players in the market that see a value in providing hydrogen for these vehicles and mobility. Most recently, there was actually a major announcement in California where over 100 plus stations will be built out in the next 5 or so years. And it was awarded to Shell, Iwatani, and First Element. That'll be really the key partners in that. And we have a direct relationship with all three of them very strong to help ensure that network grows. But also recently, we announced an MOU with Chevron. So it's a number of different discussions, but how they can really jump into the space, understand demand, think about policy advocacy, and a number of different items where we can start a direct collaboration with the Chevron team as well. So now we shift a bit away from the light duty side into what we're doing on heavy duty. And first I put up, apologize, probably my busiest slide here to just showcase how many different opportunities there are. And this was actually a publication put out by the Hydrogen Council just to showcase the timelines of really how they view the development for all these mobility applications, but also non-mobility applications, including industrial uses, among other things here. And so you could note that many things are happening really in a pretty short amount of time. A lot of them already started getting to commercialization, especially forklifts. But you looked at trucks, trains, buses, aviation, all these things coming down the pipeline, and more companies making announcements of how to decarbonize these more difficult to abate sectors on the roads. So this really is driven a lot by policy, right? So again, if you really look to California and now other states, and eventually even to the national level, and of course the global level, there is this huge drive and this huge need to move to cleaner transportation. And from the truck perspective, there's now regulations in California driving both sales and purchase mandates. And you have about 16 other states within the US that have also started to follow this goal and follow this model. And even as recently, I think New York, just maybe a couple of weeks ago, I've had a lot of workshops on this as well, including the Pacific Northwest, maybe on the other side. But at the end of the day, to get accelerated development, you really have to look to the incentives as well. So there's, bringing funding for both the infrastructure, the hydrogen production, and the vehicle to help get more of these trucks on the road and more of the diesel vehicles off the road to meet a lot of the targets that are set forth by both the ports and the policymakers. So as Toyota, we actually saw this as a huge opportunity, right? So we really a traditional light duty manufacturer, haven't really focused much on applications much bigger than the Toyota Tundra as an example. But here we saw the modularity of fuel cells could be used to decarbonize many of these other applications. And we thought, why not start big? Let's start with the largest Class 8 trucks on the road that can tow 80,000 pounds and see if we can build from that same fuel cell technology, take 2 of those vehicles in stacks, put them in one of these existing trucks from other manufacturers, and see if we can make this work. And that's exactly what we did here with those initial prototypes at the top there. Built our first one in 2017, and then the next one just a year later in 2018, called them the Alpha and Beta truck. And we created this proof of concept that indeed we could scale our existing technology along with a number of other suppliers to build a Class 8 fuel cell electric truck with 0 emissions. So we've now moved from those initial prototypes into really much more of a demonstration. So there in the middle, we're now working directly with the Kenworth truck company, PACCAR company, to collaborate and develop those 10 trucks. So now we have this demonstration, 10 trucks on the road with 4 actual operators doing real work. So this is our internal car fleet. It's actually delivering vehicles from the ports of LA and Long Beach into our dealer network. We have 2 drayage partners in TTSI and in Southern Counties Express. Again, basically taking crates and containers from the ports and bringing them to their end uses. And also UPS, of course, one of the largest logistics companies in the world, and meeting their operations needs with these kinds of trucks. And so these trucks are actually now all on the road today. All 10 of them have been delivered to customers and are starting their operations here for the next few months. But then the next piece, right? So all this demonstration leads to how to really get to something at scale. And that's what we've announced more recently, getting to this production intent of the technology and working with not just the Kenworth Truck Company, but also with Hino, our partner company, for getting these two existing Class 8 truck manufacturers integrating this technology. So building from the trucks themselves, we've also made a recent announcement that the timing is key, and getting these quickly is really key to meet these needs of the state. So we've announced in 2023, we will actually integrate and assemble these modules at our largest US manufacturing plant for Toyota at Georgetown, Kentucky. And that will be available for commercial sales into OEM partner trucks, namely Hino and Kenworth, but of course we are open to others as well. And within that same time, we've unveiled the first Hino truck prototype. So just like we did with Kenworth before, we now have this second generation Mirai fuel cell technology in one of the first trucks as we develop towards commercialization for both these OEMs and the general Class 8 market as a whole. Now, again, I'm going to talk about the infrastructure. So again, without the trucks and without fuel, you really can't meet any needs of these operators. So we initially started with more R&D type facilities. You see this one here is actually at the Toyota Port facility, where we put the first station in the ground, again, about 4 or 5 years ago, and a second sister station just 10 miles up the road. And this is what really enabled these trucks to start going and getting these miles. And we now have actually about 40,000 miles of on-road real experience between all of these, 10 to 15 vehicles that we've developed so far. But we needed more than those R&D stations. So we've now partnered with Shell, and these are 3 existing stations that have finished their construction just within the last year or so. A couple down in the ports, and one actually about 60 miles inland at a major warehousing area. So we now have this local regional network within the LA basin to enable these drayage and regional routes to demonstrate the first batch of vehicles, but also continue to support some additional trucks on the road as more OEMs and ourselves bring more to bear. The other last piece here is also the hydrogen production side of things. So Toyota has actually directly invested in a newer technology, partnered with FuelCell Energy, which we call trigeneration. So this is based on, really, it's still a fuel cell technology, but it's a higher temperature fuel cell where you can input a biogas feedstock directly and produce 3 key products, namely power, hydrogen, and hot water, actually. So it's heat and water. So all 3 of these things coming out of the plant will help decarbonize our existing major port footprint, where we'll be able to get a zero emission electricity source to offset our needs, but also a very low carbon intensity hydrogen fuel, 100% renewable, that'll go into all of these trucks and actually will fill all of our light duty Mirai before they go to dealerships. So that first fill before they're sold to the customer will come from 100% renewable hydrogen. Again, this really helps meet our global needs and requirements as a company. Last couple of slides here is more on the kind of the collaborative nature. So here, the hydrogen industry is very collaborative and worked recently through the California Fuel Cell Partnership to develop a vision for heavy duty. And here, this is really the key graphic as part of this vision document that showcases how the network has to grow and expand first over the next 5 years to get those initial markets in the ports, but eventually over the next 10 to 15 years to really start to enable these regional longer haul routes that go beyond the borders of California. So while it is a California agency, we're very aware that it requires interplay between multiple states and multimodal uses to meet the needs of operators and freight movement. And this was really the key instance here for how you get to scale. And if you note there was at the bottom, you can see that the point is to get to 200 stations by 2035 with the ability to support about 70,000 Class 8 on-road trucks within that time frame. Another key metric from this document is really a highlight of the 2. So I've talked about light duty and the Mirai, and now I've talked about the heavy duty for the fuel cell trucks, but the 2 actually work together very, very well. From a vehicle perspective, it's all about getting the cost down. And how better to do that than leverage the economies of scale that you see with light duty. We're talking, orders of magnitude greater demand and more vehicle production. That enables you to get the component costs down for a lot of the fuel cell stacks and other components themselves. So by leveraging that development into the trucks themselves, rather than a completely separate technology, you can actually take advantage of lower cost components and see that as the scale continues to grow for both of the vehicle technologies. But on the other side of the equation is the vehicle use. So of course, we still have hydrogen today that we're trying to bring the cost down as well, which also benefits from scale. But if you think of a truck use versus a vehicle, a light duty vehicle use, it maybe is 40 plus times the amount per day of hydrogen difference. So by simply looking at these two things together and taking the advantage of scale for the fuel and the scale for the vehicles, the two really help grow together to reduce the cost and improve the reliability of the entire hydrogen supply chain and enable, as we call it, the hydrogen society. My last slide here, I just want to wrap up with, again, the et al. Of applications here. As I kind of showcased from the Hydrogen Council, it's not just one application or two, it's this myriad of different applications that you can decarbonize. And here's just a snapshot of some of the projects globally that Toyota is working on, whether that's buses, medium duty trucks, you see marine, you see yard tractors, even stationary power, all things that are leveraging the exact same basic technology development we've been working on for 25 plus years. And this is what we will continue to work on, continue to grow, demonstrate, and showcase how the technology can continue to meet needs and global demands of zero emission cargo transportation. So with that, I appreciate the time again today and welcome any initial questions from the team. Thank you so much, all.